So like question 3 wati, given the geometric sequence 27, 9, 3 and so on, determine a formula for Tn. Right, so let me copy this question to our board. Okay, right, so 3.3.1, 3.1.1, 3.1.1 bafuna i-formula yaka Tn. They tell us ukuthi this is a quadratic sequence, right? Therefore siyazi ukuthi formula general term is Tn equals to a Rn minus 1, where a is the first term. In our case a is 27 and the common ratio is equals to term 2 over term 1, which is equals to 9 over 27, and then 9 over 27 is 1 over 3, right? Therefore formula general term is Tn is equals to 27 times 1 over 3 to the power n minus 1, right? So Tn is equals to 27 times 1 over 3 to the power n minus 1, right? Okay, so and then question 3.1.2, but why does the sum to infinity for this sequence exist? So we know that for a sum of to infinity to exist, the common ratio must be between minus 1 and 1, right? That is, r must be greater than minus 1 and less than 1, right? Since r is 1 over 3, then this condition holds, right? Therefore this sequence will converge. This sequence will converge, and then the sum to infinity does exist, right? Because our common ratio is between minus 1 and 1. And then 3.1.3, they want us to calculate that sum to infinity. Formula is sum to infinity is S infinity a equals to 1 minus r, right? So in our case a is 27 and r is 1 over 3, right? So punching this in your calculator, you get 27 divided by 1 minus 1 over 3 is equals to 81 over 2, right? And then this is equals to 40.5. That is the sum to infinity. Okay, asiqhubeke question, uphendule question 3, right? And then sesino 3.2 nalana. Let me copy 3.2 and create space here. Okay, so sino 3.2, but it determine but 20 water tanks are decreasing in size in such a way that the volume of each tank is 1 over 2. The volume of each tank is half the volume of the previous tank. So if this tank, this first one, is 20 centimeters cubed, this second one will be 10 centimeters cubed, this one will be 5 centimeters cubed, right? And then and so on. So if you know the volume of the first tank, you can determine the volume of the second tank. So notice the way this progresses, it forms a geometric sequence, right? Because to get the volume of this next tank, you have to take half the size of the previous tank. So this is a geometric sequence, right, with the common ratio of 1 over 2. So now, but would it be possible for the first water tank to hold all the water from the other 19 tanks? And then we have to motivate our answer. So we have this first tank, ne? They tell us what it's empty, right? But the other 19 tanks are full of water. So if this first tank is empty, if we take the water from the other tanks and pour that amount of water into the first tank, will this first tank be able to hold that amount of water? So we have to prove it and then justify our answer, right? So let us solve it. Okay. Right, so ish again given spaces enough lah. Okay, as per anyway. Okay, we'll refer back to the question. Okay, so but the first tank is empty. So the first tank is empty. We want to prove that it will be able to hold the amount of water of the other 19 tanks, ne? So if we let the volume of the first tank be x, if we let the volume of the first tank be x, let the volume of the first tank be x, ne? So let x be the volume or be the size of the first tank, the volume of tank 1 of the first tank. Let x be the volume of the first tank, right? So if x is the volume of the first tank, then the volume of the second tank is half the size of the volume of the first tank. Then the volume of the third tank is half the size of the second tank. So the volume of the third tank will be like this, right? So here we have the first tank, the second tank, the third tank, the fourth tank will be and then it carries on this way up to tank number 20, right? So we want to calculate what if we add the volumes of the other 19 tanks, will they amount to x, or will they be greater than x, or will they be less than x? So now we have a geometric sequence, ne? Right? So let us discard this first one, right? Let us discard the first tank and then take the second tank as our first term, right? So this one will be our first term up to term number 19, right? So we have a geometric sequence here, yeah? We have a geometric sequence with the first term being x over 2 and the common ratio being 1 over 2, right? So now if we want to calculate the sum of the volumes of all the tanks and check are they greater or equals to or less than the volume of the first tank, will then we can justify with him the first tank will be able to hold the amount of water of the other 19 tanks or not, right? So because we have a geometric sequence, we can sum the terms using this formula here, 1 minus r n divided by 1 minus r, since r is less than 1, right? So we know our first term is x over 2, right? And our common ratio is 1 over 2, alright? And then we are summing 19 terms, right? We are summing 19 terms. Okay? So now if I sort of like pull out x outside this fraction, so it's 1 over 2 times 1 minus 1 over 2 to the power 19 divided by 1 minus 1 over 2, right? And then if you punch this whole thing in your calculator, you will get x times, okay, let me punch it. You'll get x times 0.999, x times 0.999998020927. And then notice ukuthi this number is less than 1. This 0.999 is less than 1. Therefore, we can say this will be less than x times 1, right? Which is just less than x, which means this is less than x. Okay? So therefore, because when we take the sum of the volumes of the 19 tanks, their sum is less than x, it means that the first tank will be able to hold the amount of water that is in the other 19 tanks, because the sum of their volumes is less than x, right? So now we can justify our answer and say yes, the first tank will hold all the water from the 19 tanks, right? From the 19 tanks. So that is 3.2. Okay, yeah, that is 3.2. and then now we go on to 3.3. Let's create a space for 3.3. Okay, so 3.3, we have a formula for Tn lapha. So 3.3, but the end term of a sequence is given by this. So we know what this is a quadratic function, therefore we have a quadratic sequence here. But write down the first 3 terms of the sequence, right? Let us write down the first 3 terms. So 3.3.1, but write down the first 3 terms. So if you substitute 1 in that formula, you'll get T1 is equals to minus 14, T1 is equals to minus 14, right? And then T2 is equals to 0. When you substitute 1 in that formula, we'll get T1. When you substitute 2, you will get T2. And then when you substitute 3, you will get term 3. So when you substitute 3, you will get 10, right? So write down the first 3 terms of the sequence. So the first 3 terms is minus 14, 0, 10, right? And then bati ku 3.3.2, but write the term of the sequence which will have the greatest value. So if you look at this function here, it's a quadratic function, and then it's in the form of, if you think from our functions, right, it's in the form of ax minus p squared plus q, right? So it's a quadratic function, and then because the value of a there is negative, the value of a is negative, shape yakhona siyazi ukuthi, so it has a maximum point lapha ku turning point, right? And then our coordinates where turning point is, we know ukuthi it's p and q, right? So this function, this one, will have a maximum value at the turning point, right? Because of the shape. If the shape was positive, if the graph was like this, then we'll have a minimum value at the turning point. But because the shape is like this, the maximum value will be at the turning point, yeah? And then the x coordinate of the turning point is p, and the maximum value is q. The maximum value is q there, right? So here, when you look at this function, this sequence will have a maximum value of 18 when n is 5, right? So, but which term of the sequence will have the greatest value? So there you'll just say T5 will have, term number 5 will have the greatest value, right? And then term number 5 is 18, né? So by just writing down T5, you'll get your 1 mark there. And then 3.3.3, but what is the second difference of this quadratic sequence? So to get the second difference, let us calculate term number 4. Term number 4 is equals to when you substitute 4 in that equation, you get that term number 4 is 16, right? We already have the first 3 terms, so sizoba no minus 14, 0, 10, 16, ne? And then now we calculate the first difference, right? When you say 0 minus 14, you'll just get 14. When you say 10 minus 0, you'll get 10. When you say 16 minus 10, you'll get 6. And then now we'll calculate the second difference. Yeah? So now the second difference, you'll say 10 minus 14, you'll get what that is minus 4. And then out is 6 minus 10, that is minus 4. Therefore, the second difference is minus 4. Okay, I think Palama answers lawa lapa, then Sule to create space for 3.3.4. So term number 5 will have the greatest value. The second difference is minus 4. right? And then we have the first three terms lapha. It's minus 4, 14, 0, 10. It's minus 14. Oops. It's minus 14, 0, 10. Okay. Now see, I go 3.3.4. Go 3.3.4 what it determine all the values of n for which the terms of the sequence will be less than negative 110. So now this takes you back to the understanding yama functions and graphs, ne? Like how do you determine if you have a function f of x equals to a x minus p plus q? How will you determine the x values where the function is less than 0, say, right? So to determine the values where this function is less than 0, you want the values of x where this function will be less than 0. So to get those values of x where this function is less than 0, you will first calculate the values of x where that function is greater than 0. And then let's say, because it's a quadratic function, let's say you get the values here. Let's say you get uti, maybe just as an example, let's say maybe you get uti the function is equals to 0 at 5 and is also equals to 0 at minus 2, right? So uzobona ukuthi the function is less than 0 in a Cartesian plane in y x. The function uzobona ukuthi it's less than 0 where x is greater than 5 and when x is less than minus 2, because ila graph yako ifola under the x-axis. That's where the function is less than 0. So the same will apply here. To get the values of x for which, to get the values of n for which this function will be less than negative 110, we'll first have to get the values of n where that function is equals to negative 110, right? So now so now we have Tn as our function minus 2 n minus 5 squared plus 18, right? So in this case we want the values of n where this function will be less than negative 110, right? So let's start by, let's get the values of n where the sequence, the values of n where the sequence, sorry, let's get the values of n where this function, let's get the value, it will be a value here, not values. Let's get the value of n where the sequence will be equals to, where this function Tn will be equals to negative 110. This we know how to solve already. So we will say 2 minus 2n minus 5 squared plus 18 equals to negative 110, right? So now we now solve for n, right? Dividing throughout by minus 2 no n minus 5 squared minus 9 equals to positive 55, right? Equals to positive 55 equals to 55. Right, so now we're solving for n, right? We want the values of n where the function will be equals to that number there, right? So n minus 5 squared will be equals to 55 plus 9 is 64. So n minus 5, when you take square root both sides, you'll get that n minus 5 will be equals to, the square root of 64 is 8, will be equals to 8, or n minus 5 will be equals to minus 8, right? So n will be 13, or n will be minus 3. So already we know that n cannot be negative, so this one we discard, ne? So we focus on 13, right? So now the function is equals to minus 110 when when n is equals to 13. If you go back to your formula, or the formula for Tn there, and substitute n equals to 13, so when minus 2 times 13 minus 5 all squared plus 18, so that's equals to 110. So Tina, we want the values of n where the function is less than minus 110, not where it's equals to. So we know what it's equals to 110 when n is equals to 13, ne? Right? So if you draw sort of like a picture here, that function you'll have Tn, and then you'll have n. So we know what that function is, okay, so when n is equals to 1, that function is minus 14, so we will be somewhere here, right? So our function, sort of like a sketch, will be like this, that function, and then this is the maximum value, will be 18, right? So at some point here, this function will be equals to, sorry, how do I explain this? Okay, how things are moving as a mono, n minus 5 equals to what? Minus 8, density n equals to, right? So now we have this sketch, right? We know when n is equals to 13, this function here will be equals to minus 110 at some point, will be equals to minus 110, ne? This is just a picture to demonstrate, ne? And then we want the values of n where this function will be less than 110. So when you go to the right of 13, already you see what this graph falls below minus 110. Therefore, when n is greater than 13, the sequence will, the values of the sequence will be less than 110, right? So therefore, when n is greater than 13, the terms of the sequence will be less than 110, because when you go to the right of 13, when you say 14, 14, 15, 16 and so forth, uzokubona ukuthi the values of the terms after 13 will be less than 110, right? And then yeah, they will be less than 110, right? So this picture is just for explanation, right? If you are able to see uti for values of n that are greater than 13, the terms of the sequence will be less than 110, minus 110, then you don't need to draw any pictures here. But then for me now, I usually draw pictures for such questions. Okay, so I think we are done. Yeah, we are done with this question. Yeah, that's it for this video. If you khona ungakuzwisisi, feel free ukuthi ungazise lapho ku WhatsApp, ngizama ukuthi ngichazele ngcono. Okay.